Ladies and gentlemen, good morning. Good afternoon even. My name is Johnson-Poensgen. I'm Chief Executive of Circulor. This is Mark Rakhmilevich from Oracle. And we want to explain to you what we've been doing for the last year or so with a European car manufacturer called Volvo. And the work that we're doing here actually is starting to form the foundations for a wider network of car manufacturers trying to deal with some challenges around responsible and ethical sourcing and the carbon footprint of electric vehicles. So what we want to do is start with a description of the business problem that we were trying to solve, the approach we took to doing it, and then delve down into the underlying technology. And Mark is also going to talk a little bit about the roadmap that Oracle has got for its blockchain platform and how this will potentially help solutions like this scale. So responsible sourcing is now a mainstream business issue. Although this is a pretty picture, the reality is that our collective desire for stuff as consumers is driving the exploitation not only of natural resources, but challenges like deforestation, as well as child labor in the supply chains. And increasingly, whether it is pressure from institutional investors through ESG or from consumers and regulators for responsible and ethical and sustainable business, this is something that major brands are actively grappling with. And what blockchain gives us is the opportunity to start to digitize very diverse supply chains in an effort to demonstrate that they are indeed behaving responsibly in their supply chains, if indeed they are. Now, the cost of responsible business today, the OECD estimates at some 25 billion. I think that's probably an underestimate. But today, that cost is largely spent on internal resources that are effectively doing sort of responsible business type roles inside corporates, plus the cost of spot audits within supply chains. So some materials like, for example, minerals are already relatively well regulated by industry bodies such as the Responsible Minerals Initiative, and there are a whole variety of audits that are done to OECD standards in those supply chains. But beyond that, beyond responsible sourcing, there are significant challenges around things like the carbon footprint of the supply chains of some of the things we buy. Something that many of you may not know is that the carbon footprint of an electric vehicle, for example, is far, far higher than the carbon footprint of a petrol or diesel car, up to about 50,000 miles. And the reason for that is the supply chain. Not only the enormous distances traveled between mines in Australia or Africa and refineries in China and battery manufacturers in other parts of Asia or China, and then to car manufacturers, plants all over the world, but actually the fact that so much of the power intensity required for things like chemical refining of materials like cobalt, which are essential to lithium-ion batteries, comes at the moment from unsustainable electricity or unsustainable power sources like coal-fired electricity. And so there's some quite neat little stats on this. The carbon footprint of a Tesla compared to a 7 Series BMW, is way higher in production. Of course, there are no tailpipe emissions except for potentially unsustainable electricity in the life of the electric vehicle, and that's why the two start to even out over time. And that's before you take into account the recycling of things like electric vehicle batteries. So Volvo has set itself a challenge of becoming a genuinely sustainable car manufacturer, not only to be carbon neutral by, in their case, the target they've set themselves is 2040, and by that I mean carbon neutral not only in their own plants but also their entire supply chain, but also to extend their brand promise. The Volvo brand, for those of you who know, has always been synonymous with safety. Their adverts from the 1950s were about a child in the back seat, and it was always about keeping your family safe. And they've extended that to a brand promise that says, look, the safety of your children is not just about what happens inside the car, it's as much about the world that they grow up in. We have an obligation to source responsibly, not to exploit the poorest people on the planet or to exploit the planet in our pursuit of profit. And actually that sounds like quite a natural extension of their brand promise given Volvo's particular reputation. So it's not a surprise that Volvo is one of the first car manufacturers to have actively tried to pioneer the use of a new technology to make responsible sourcing happen. To give you some sense of scale, and you can see some statistics on the slide here, they're looking for 50% of all of their vehicles to be electric by 2025. Similar ambitions from many car manufacturers, and they think that by 2025, they will have sold approximately a million electric vehicles, which is modest compared to, for example, Volkswagen. But given the standard they have set themselves of both carbon neutrality and being certain about the provenance of the materials they're using, there's quite an interesting logistical challenge in there. I don't know how much you know about supply chains, but supply chains obviously are not chains. They're networks and meshes. They're complex. And if you take somewhere in the middle of a supply chain, like the Cobalt supply chain, at the moment, the majority of the purchasing decisions are taken largely on price, and there's a reasonable amount of spot purchasing in the middle of the supply chain to get the best price of, for example, your precursor material or your cobalt hydroxide or whatever. And the challenge with that, if you're trying to demonstrate responsible sourcing, is actually where the hell have you sourced your material from that's ending up in your batteries? And secondly, if you're trying to manage a carbon footprint down to net zero, how can you possibly do that with a static life cycle assessment if you don't understand the flow of the materials through your supply chain? And if you think about an electric vehicle battery, cobalt is one of those constituents, but obviously you have lithium, which comes with environmental concerns. You have mica, which has the same child labor issues as cobalt, except in this case, it's children in Madagascar that are digging it up rather than children in the Congo for cobalt. Steel and aluminium obviously have a significant energy footprint in their manufacture and therefore create quite a lot of greenhouse gases. So the flow of materials actually starts to unlock a number of serious challenges for you. The other aspect of this is that when you have digitized a previously undigitized supply chain from mine to manufacturer, you can start to imagine how you could potentially start to increase the efficiency of that supply chain, even just by reducing working capital requirements by a few percentage points at different stages of the supply chain. You can actually reduce the overall cost of an electric vehicle battery, which is the single most expensive component. So leaping forward then, given that we're talking about something that's already live, we just want to show you an extremely short video that sets the context for this before we explain to you how it actually works. So there are two broad approaches to trying to do this in a supply chain. One approach is to track the commercial transactions between participants in the supply chain and use that as a proxy for a chain of custody of the material. Our contention was that wasn't good enough, because just because you've got 10 tons of good stuff going onto a stockpile of 100 tons of raw material does not mean that what you've ended up with in your own battery is the responsibly sourced proportion. And so the alternative approach is to give an identity to a blob of commodity and to follow that all the way through the process. Now, the complexity, of course, is that you dig up a pile of ore, and then it goes through smelting and refining, possibly a number of steps of chemical refining until it becomes a refined material and then is amalgamated with other materials, for example, to create nickel, cobalt, manganese precursor. And that's then put onto a cathode, which is mixed up with all the other ingredients that make a battery cell. And so the challenge is to firstly create a reliable digital twin for a material that has no unique physical form. So it's not a diamond that remains a diamond all the way through the supply chain, and it's also not something that you can scientifically measure with certainty. But you obviously don't want to give a veneer of respectability to any old stuff. So the process to create a digital twin is really important. And then you want to be able to follow that all the way through the supply chain. So how do we do it? Imagine now for a second you're standing in the rain in a muddy puddle in a mine site in the Congo. And we have a mobile signal, but we have no other technology. By the way, the mobile signal in most parts of Central Africa is way better than we find in London. I'm not joking. We've developed a mobile app as a way of creating that digital twin, and that mobile app does a number of things. First of all, we're interested in the identity of the individuals involved in that first transaction. To log into the app, you need to use your face, and the first step of creating any scan for material is actually a photograph of say, the pit manager that's bringing material to a collection point. Not because, John doesn't know Bob, but because what we're trying to record is that a known counterparty or one of your employees brought material to a mine site, to a collection point. The second is you need the location. Now, we're at the moment dealing with licensed mine sites, and so those that have been audited and are licensed. Now, that location comes from the phone. The challenge, of course, is, and we have Pokemon Go and dating apps to thank for GPS spoofing. You can clearly just download an app, certainly on Android, and claim to be somewhere that you're not. So we've had to build a number of defenses against GPS spoofing into the app in order to be confident that someone is where they claim to be, or at the very least, to know that they're trying to spoof their location. Then, of course, you need to know the composition of the material, including its weight. Handheld mass spectrometers are used routinely at mine sites because you don't want to pay your mining teams for any old dirt. You want to pay them for good dirt. And so we can record that information off the handheld mass spectrometers. Looks a bit like a large gun. And then the final point is attaching an identity to it, which is a tag. Of course, there are lots and lots of types of tags that you could use, but the challenge we actually set by the Rwandan government was, could you come up with a tagging scheme that was essentially free? So our platform produces QR codes that have attributes, i.e. they can only be used by you this month in this mine site. And you can effectively create the tags on a tamper-proof plastic tag yourself for next to nothing. It's not totally free because you've got to buy the tamper-proof tags. You need a black and white printer. But the idea was that it was effectively free, and compared to existing, relatively mandrolic paper-based traceability systems which already exist for bag and tag schemes, such as for tin and other conflict minerals, it is effectively free by comparison. So that's how you create your digital twin. And of course, as you go into every one of those chemical or manufacturing processes, they all follow a recipe or a known process. So imagine a chemical refinery. It's a bit like baking a cake. You start with 1 kilo of flour, you can't make 50 cakes. Apply that to a chemical process, you start with 1 ton of stuff, and you should be able to create 500 kilos, depending on certain tolerances of the product that you're interested in. So we use tests like mass balance, elapsed time, proof of location, and if there is a process involved, scan points through that process in order to reliably connect the input ingredients to the output product. And it's then that the output, which now has a completely different chemical composition to the input, can inherit the identity of the input material. It's exactly the same as your own biology. Every one of you shares your grandfather's DNA. You're clearly a different person. And it's the rules of biology that dictate how you inherited that identity. And here it's the rules of chemistry and of mechanical engineering or process. And that is repeated at every single step of the journey. The grayed out circles represent a track and trace challenge. So although there might be a little bit of oxidization of an ore on a ship as it crosses the Pacific, its fundamental composition isn't changing between the port of departure and the port of entry at the other end, even if there is a little bit of oxidation. So I'm not minimizing it, it's complicated, but basically it is a track and trace challenge. It's not trying to code the chemistry effectively. So that sounds complicated, but to the upstream user in a mine site, it's a mobile app, and to the downstream user, if you're a car manufacturer like Volvo, what you really want to know is, where are the anomalies in my supply chain? Can I trust that this material has been responsibly sourced? And we use Oracle Analytics Cloud to present the data that is captured all the way through the supply chain in a way that actually helps direct compliance attention at those bits of the supply chain where there might be issues. The platform is supposed to be, or the platform is agnostic of how you access it, and there's obviously a lot of stuff behind this, but for the majority of users, it's basically a dashboard, because that's what they currently care about. What we've tried to do is provide the benefits of coalition without the constraints of a consortium to customers. So, and I'll talk about this a little bit in a second, but the carbon tracking we've just done with Daimler, for example, piggybacks off the material flow tracking we've done with Volvo. They don't have to be formally connected, but they know that they're part, effectively, of a coalition rather than a formal consortium. And we've done that deliberately in an attempt to avoid some of the constraints and challenges of a formal consortium, where you can nevertheless give the benefits of collaboration without necessarily having to tie people together in a way that they're not yet comfortable to participate together. So how long did it take? We started our business in 2017. We started working formally with Oracle in the summer of 2018. Our first field trials were in Rwanda for a conflict mineral called tantalum. There's a case study of that on the Hyperledger website now. And we started a pilot with Volvo Cars in January 2019. And that was the first time a car manufacturer had attempted to follow a material like cobalt from mines, actually we started with recycled scrap lithium-ion batteries, but follow a material from its source all the way through the production process to the actual battery that they were going to be putting into a car. And after a successful pilot, we then started a process of going live. So today, CATL and LG Chem, which are probably the two largest electric vehicle battery manufacturers in the world, are now on our platform, together with their tier 1 and their tier 2, and in one case, their tier 3 suppliers as well. So we actually have complete traceability from licensed mine sites in the Congo that are producing ore, as well as from scrap lithium-ion batteries that are going through the recycling process back to the new batteries that are being created. Now, what's exciting about this, of course, is that CATL and LG Chem make batteries for lots of other people, including Volkswagen and Daimler and Renault and PSA and General Motors, and you get the idea. So the network is building already as others come forward and say, look, Volvo's done the hard yards, how can we piggyback off the back of it? And I'll unpack that a little bit more in terms of who's coming on board. I talked through some of this. The process of battery manufacturing involves many, many steps. I'm not going to tell you what they all are, but the point being that every single one of those circles represents a step in code the chemistry that I was talking about earlier. And at every one of those steps, went the wrong way. At every one of those steps, we are interested in a timestamp, a location, the identity of the input to that process, the identity of the output to that process, which is assigned to it. It's not connected until the rules are successfully passed. Elapsed time is very important to some of these processes. For example, the sintering of lithium with NCM precursor can, depending on the process you take, is either 2 days or up to 13 days. So clearly you can't drive a lorry in on Monday morning, drive a lorry out on Monday afternoon and claim it's the same material. And so essentially at every one of these steps, we're collecting data that allows you to prove input became output. And with that, I want to hand over to Mark, who's going to talk to you about the underlying platform on which we've managed to build this.
All right, thanks, Doug. So as you saw, this is a very interesting journey that uses a lot of sophisticated technologies that Circulor provides to really track all of the different phases of the material as it goes through various transformation steps. And of course, the underlying data is being logged into a distributed ledger on the blockchain. And as Doug mentioned, we've started working with Circulor a few years ago on helping them to create the solution leveraging Oracle blockchain platform. Our blockchain platform is Hyperledger Fabric based with a number of enhancements for making it easier for enterprises to adopt and quickly deploy and provision and manage and secure and all of those other things. It's a platform that's been available since middle of 2018 as part of the Oracle Cloud. So it's a managed blockchain as a service platform, and it provides interoperability with other Hyperledger Fabric instances. So if you have networks that span Oracle and let's say IBM or SAP, Microsoft, etc., Hyperledger Fabric nodes, you can link them all together. We also provide a lot of integration capabilities to simplify how the data gets collected, whether it's through REST APIs, integration adapters from various ERP systems, which could be running in a cloud environment, could be running on premises, maybe Oracle or non-Oracle. Doesn't really matter. There is a lot of integration capabilities built in to simplify the process of onboarding that, and then a lot of enterprise-grade stuff to make it secure, make it highly available, resilient, and so on. And I'm not going to go all of the details here, but it's a platform that helps to speed up the process for companies like Circulor and many others in terms of creating a solution, deploying it in a ready-made blockchain environment so that they can go forward and very quickly present it to customers. We have done a lot of work to enhance the Hyperledger Fabric open source, but still in a compatible manner so that we continue to ensure full compliance, compatibility with the protocols, with API, interoperability with other Hyperledger members, but also add capabilities around things like REST proxy, for example, for extensive set of REST APIs to simplify the integration, management monitoring capabilities, ability to use SQL, for example, inside the rich data queries in the smart contracts, ability to connect analytics tools through our data warehouse and analytics integration, which Doug had mentioned. And so really a platform that's ready for production from day one. You can experiment and create an environment in the cloud in 5 or 10 minutes to start actually piloting something. But if you're ready to go into production, it has basically all of the capabilities that you need. And the goal for this platform is to really make it easy for people to create solutions by making it first easy to deploy and provision, whether it's in a cloud environment, and we also have an on-premise version available now. Easy to integrate with a variety of systems that you have in the back office that are providing the data, driving transactions, or consuming the event. Easy to control member access by using privacy confidentiality capabilities, fine-grained access control lists, among others. Ability to easily monitor and manage, create basically dashboards that track all of the transactions. Ability to see who's doing what on the network, add members and all of that stuff, and extend it beyond the initial scope, as we'll talk about. But what really makes it even faster is the fact that we can surround it with additional capabilities, because often it's not just a blockchain itself, they're just an enabler, but many other things like the integration capabilities which we provide through Integration Cloud, data warehouse in database as a service or autonomous data warehouse, analytics cloud. All of those things basically are snap-in blocks that you can quickly provision in an Oracle Cloud environment. And then what you're going to do is you're going to do some development work on top of those platforms, but it's much, much faster than doing it from scratch. So you can essentially create accelerators and templates that allow you to speed up those processes and customize them for any new customer deployment through the integration orchestration, through the template smart contracts, dashboards and analytics cloud. Most of those things do not require coding or low-code environments, like the integrations or the analytics dashboards. Smart contracts do require some coding, of course, and the front-end application. And you're going to see in the architecture coming up here that Circulor has built an application on this infrastructure to actually take to Volvo and all those other providers in that space. Turn it over to Doug.
Yeah, so I mentioned the mobile app. As a part of that, there's also an application which allows us to define the workflows in an individual supply chain, as well as capture information about every participant in that process. Imagine, for example, a mid-tier refinery that is undergoing or is subject to audits, for example, against OECD guidelines. Its audit reports and other data that is relevant to those participants downstream that are using their material all has to be recorded. The business logic that ties together the ingredients of the chemistry that I was talking about earlier all needs defining for individual supply chains. And although we're talking here about Cobalt and electric vehicle batteries, we're doing this right now, for example, for mica, which is used, mica paper is used for heat insulation in electric vehicle batteries. And I mentioned earlier, they've got pretty much the same challenges. And we're just starting to tackle lithium as well. So every one of those is a completely different supply chain. Mark. Now, kind of obvious, but the process of going through an implementation starts with the mapping of a supply chain and understanding the unique challenges in that supply chain, which I've talked about, and then the configuration of the platform in order to be able to follow that chain of custody all the way through the supply chain. User training actually has become relatively simple. We give customers access to a sandbox beforehand, so they kind of had a chance to play around with it while we're doing the first two steps. And we offer this as a managed service to our customers so that they don't have to worry about any form of configuration or anything else, and bundle an amount of support into it as well, which thankfully at the moment most aren't using, largely because the Oracle platform just works out of the box for us. So to give you an idea of time to implement, moment. We in the Cobalt supply chain took us a few months. The mica supply chain we've managed to do in weeks because, of course, we've learned quite a lot about how to actually map a supply chain and precisely what we need. We now do it in the office because we can think through these supply chains. And I've employed geologists, for example, to help us precisely what we're looking for when we turn up at a mine site in the middle of Russia. So I've got guys right now in Kovdor, which is south of Murmansk in Russia, looking at mica mines, and they only need to be there a day, and it'll be like that for every single step of the supply chain. So where next? Daimler approached us after they'd read about what we'd been doing with Volvo, because they share the same battery manufacturer, and said, look, yes, we'd like the responsible sourcing stuff, but actually it'd be quite cool if we could actually understand the carbon footprint of our battery. I talked about it earlier, but Daimler has therefore pioneered a new use of exactly the same underlying chain of custody. We've just started working with Boeing, for example, because aerospace recognizes it has exactly the same challenges of responsible sourcing. And of course, the carbon footprint of aerospace is not just the use of the aeroplanes, it's of course the supply chain before it. And so they're looking to do exactly the same thing as the car manufacturers have done. Volvo Trucks is doing something similar. Again, that'll be a project which we'll be working on with Oracle, amongst others. And then separately, more broadly than that, the Finnish Mining Group, which is a government-owned entity that runs mining operations in Finland, is actually in the process of trying to create a complete platform for the entire circular economy of European battery materials, which takes this beyond the first use through the life of a car battery all the way into its second life and hopefully multiple cycles of recycling. So this has the potential to build quite a sizable network off what were some initial projects like the one we've described to you today.
All right. So I thought we'd just talk a little bit briefly about how we actually work with customers and partners to drive the future of our blockchain platform. Because, as you see here, there is always a future project. There is always going to be an expansion. There is always going to be a need to grow and evolve. When people deploy something, it's not like a done deal. That's it. It's done. It's running. You can basically take a break and go on to the next thing. There is always going to be a set of requirements to do things better, faster, more secure, and so on. So we have, from a blockchain platform perspective, significant areas that we're investing in development, making it easier to develop applications, whether it's a smart contracts or the client component sitting on top. Security, confidentiality, privacy is always a big concern, and we're doing some work around fine-grained access control list mechanism. Trusted data sources, IDEs and chain code development aids, so that it's going to be easier and faster to develop the next set of chain codes. We're doing some work around token-based chain code capabilities. As you know, Hyperledger Fabric does not have an inherently built-in token like public networks, but there are certain areas in a business environment, not anything to do with cryptocurrencies, but in business applications where tokenization makes sense, whether it's for financial institutions or tokenizing some of the assets. And there is some work that we're doing in that area as well. Operations is very important. You're going to have an application that's going to be business critical, and you're going to depend on it running 24/7 and people inside your IT organization to support it and so on. So it has to be an application and the system underneath that application that really meets those requirements. You're going to need to onboard the members, and so we're doing a lot of work around simplifying governance. There is capabilities today in Hyperledger Fabric to manage the consortium, but at a very basic level. There is more that's required. And you need to be able to come up with mechanisms that allow multiple organizations to agree to add a new member, to create a new channel, for example, or to deploy new smart contracts or chain code. And all of those things today are done off-chain. They're done when people get together in a room. So when you have Volvo, 5 or 6 other organizations, it's easy enough to get on a conference call or a WebEx session, et cetera, and do that. Imagine when this network scales to 20, 50, 100 participants, you're not going to be able to do those kind of governance processes informally. You're going to need a more on-chain based governance mechanism that is going to allow all of those decisions to be tracked. People will need to be able to vote on certain things that are being proposed. And again, you want to be able to use the trusted capabilities that the blockchain itself provides to manage and automate all of those processes. There is also work on the infrastructure side. Doug mentioned that one of the interesting things about here is that you have a lot of raw materials that are going to be traveling to China, for example, or Asia for refining and smelting, and then the parts are going to be produced and they go elsewhere. Well, in each country, you're going to have specific requirements and regulations around how you deploy your blockchain. If it happens to be in China, there is a lot of very specific regulations about local deployments. And so we're going to need to provide, and we're already providing actually an on-premise version of our blockchain platform so that customers based in China can follow those regulations and they don't have to necessarily deploy it in an Oracle public cloud, they can deploy in their own data center. But we're enhancing those capabilities as well. We're adding things around making it more resilient, adding security capabilities, HSM integration, and so on. The other area that's of course going to be equally important is interoperability across different networks. You're going to have islands that need to be able to interconnect and share the data. And so whether it's interoperability between different Hyperledger Fabric networks, which is already possible, technically just needs some engineering work, or interoperability between, let's say, Hyperledger Fabric and Corda-based or Ethereum-based networks, which requires a lot more research because there is really no good, clear solutions yet for interledger type connectivity across different stacks. Those are some of the areas that we're investing in, and we're essentially taking the clue from folks like Circulor and the customers like Volvo to know where to go, where to focus on, right? So a lot of our investments at Oracle are driven by those customers that are on the leading edge of blockchain projects that are actually already in production and looking to expand and scale that and go to the next step. So just a little bit on that. And just to close with some summary and links, you can get more information on oracle.com/blockchain. That's kind of the main page. Everything Oracle is doing around blockchain space is there. You can actually try the blockchain for free. You can sign up for a free trial on our cloud. Or you can download an on-premise edition and run it on your laptop. It's available basically as a virtual machine appliance. You can download and run on VirtualBox, VMware, etc. There's some developer ebooks out there, and there is a new book that's been published actually available on O'Reilly and many other places, Oracle Blockchain Quick Start Guide, which provides a great overview of all of the capabilities. So with that, I'll just go to the last slide and we can take some questions, I think.
We've got a few minutes for questions, so hi. Should we start at the front?
Hi, this is Laszlo. So my understanding, you use Hyperledger Fabric and bias to that. However, have you thought about or considered software?
Yeah, so our first prototype was actually on Ethereum, because our second prototype was on Sawtooth, and then we built our production platform on the Oracle Hyperledger Fabric platform. So we experimented with other things. Before we decided on Hyperledger Fabric, we actually looked at Corda as well, but concluded that and this was more of a business decision than a technical decision, I thought that it made sense to go with something that was considered to be the enterprise class blockchain for, that was more appropriate to, for example, a supply chain. Corda, obviously, although it's been sort of broadening its sphere of influence, the reality is it was built initially for, financial services use cases, and two and a bit years ago, that's really the balance we had to make. Hi. Yeah. So the question for those of you who didn't hear it is, how does the mass balance approach work? Now, the actual unit by which most of these materials are moved around are 1-ton bags. And those 1-ton bags are sent from, for example, a smelter in the Congo with a unique identity, every bag, to the next step in the chain, which might be a cobalt refiner like YU Cobalt. And every one of the processes, certainly in the cobalt supply chain, is a batch process. So you know which 4 bags you're taking to put into a particular batch, which then creates a particular amount of output. So the mass balance obviously depends on the yield of the material and its input composition, and that varies slightly depending on where it's come from and all the rest of it. But that's the point about mapping the supply chain and knowing how the ingredients in create the right amount of ingredients out. What we're really interested in is making sure that material of known provenance is not mixed with material of unknown provenance. Yeah. Yes. Yeah, so we're starting to grapple with exactly that challenge in chemical recycling of plastic waste. So plastic waste being turned into a form of kind of waste plastic crude oil, for want of a better way of describing it, and going to the same chemical refineries that currently take the stuff out of the ground and turn it into everything from wax to benzene to aviation fuel. So we're starting to grapple with exactly that challenge. It's a pilot project we're doing at the moment with a large oil refiner. Haven't got the answer yet, but we're working on it. So I recognize your problem. Hi.
I'm curious about if you're using any kind of like certificates for regulation, for example, that the final customer knows that no slavery was used along the process.
Yeah. Yeah, so no technology will completely replace due diligence. So inspections, for example, of mine sites and smelters and refineries along the supply chain are already conducted. So they are the basic permissions that are necessary before you're allowed to join a platform like ours if you're in someone's supply chain. So that sort of physical inspection and audit won't go away. What we're overlaying it with is, if you like, a live ongoing surveillance tool, essentially, to make sure that people are behaving themselves. One of the things we found is there are remarkably few anomalies created in the supply chain at the moment because everyone knows they're being watched. It's kind of the point. Yes, yeah, well, they're put into the platform. They're actually stored off-chain, but hashed to the blockchain. Hi.
One more question. You mentioned you started 1 year ago. Like, to me, it seems a very short period of time. Like, how can you change?
We started 3 years ago. We started 3 years ago. We started the Volvo project 1 year ago, but we'd already done field trials in Rwanda with a different material, tantalum, which is used in the manufacture of capacitors, which we all have in our phones, for example. So we'd done quite a lot of work. We went to Volvo and said, we think we have a solution to your problem. So we didn't start with a blank sheet of paper with the customer's problem. We went to them and said, we think we have a solution. And they said, okay, prove it.
I'm curious how you went about engaging with the first clients when you understand that you need to form a coalition around them.
Yeah.
Do you start bilaterally? Do you start multilaterally? And how do you
So
facilitate that?
we took the decision to start with the person that has the problem. So in this case, the car manufacturer. They obviously have contractual relationships and buy batteries from people they've let contracts to. So there's a commercial relationship. And so by starting with the downstream who holds the brand risk, if you like, and if you can convince them that this is a sensible approach, then they talk to their tier one suppliers who talk to their tier one suppliers, which is really how it's worked. If we started at the other end and tried to kind of somehow capture, make up some large percentage of the global cobalt market, we'd be doing it for the next decade.
Just to mention, in our experience working with a lot of similar sort of processes where you start with a few partners and then you expand the coalitions, it tends to work better than trying to bring people together theoretically around some kind of a concept, because there is just a lot of open questions, a lot of uncertainty, and that slows things down. I mean, sometimes it works, but generally, if you can start with somebody who has a very specific understanding of what problems they're trying to solve, and 3 or 4 people around them, or companies around them that actually are part of that solution, part of the problem initially, and then become part of the solution, it tends to work better because then you have something that's already built and potentially deployed in some initial production, and then other people can see it live and they join.
We all know that requirements definition by committee is not very efficient. So start with one. Yes, hi. Yep. So we've started with trying to plot clean paths. So obviously there's a huge panoply of suppliers who will produce materials at different stages of the supply chain. The challenge was to find, and obviously it's not one to one to one to one, but the challenge was to find sufficient clean paths for the volume of material that the initial, in this case, pioneer customer wanted. As we bring on other car manufacturers, we're starting to add more. Because obviously not all the raw material can come from one. One of the things that surprised me pleasantly was the willingness of suppliers in the midstream and upstream to engage with this. I mean, obviously there's a a pile of regulation in minerals. Everyone knows that cobalt is a scarce resource. Everyone knows that child labor is a problem in the supply chain. But I had imagined it would be much harder to convince people to participate. The suppliers, tier 3, 4, 5 that we've been working with, and they're now subscribers to our platform, recognized that this was coming and actually were quite keen to be one of the pioneers because they saw it as a way of expanding their market share. Kind of obvious when I say it with the benefit of history, but I thought we'd be pushing further uphill. Any more? Yes, hi.
Again, the question of finances come in, and usually is Volvo footing the bill for the whole, running all the different nodes?
How's it paid for? Yeah, so we funded the initial development of the platform. We charged Volvo a fee for the pilot, which is effectively time materials, and now the participants are on a tiered subscription model, and tiered, the highest cost paid by the car manufacturer, and then going down through the others are paying. And so there's a kind of a tariff for onboarding a new supplier. In some cases, Volvo is choosing to pay that. So in the mica supply chain, they've chosen to effectively pump prime year one because people are otherwise faced with an unbudgeted cost. But they've said to their supply chain, year 2 and 3, you're on the hook. Hi.
As a follow-up to that thought, is there any kind of unique relationship that you maintain with the client after going live in production that you don't find in traditional delivery models?
No, we've basically copied the approach from IT services. Bearing in mind that, we're trying to land and expand with those customers. We started with Cobalt, Volvo I've described, we're now doing mica, we're talking to them about lithium and rare earth elements. I want to maintain a relationship with that customer, so it's not a fire and forget. So it is a software as a service, but it's in our interest to be relatively high touch. Hi.
How big was your team working on the Volvo project?
We started with 6. We've obviously grown since, of which roughly 50% was development resource. I have to say, and I'm not a techie, but I have to say I have a preference for slightly smaller development teams because they spend less time talking to each other, more time building. So forgive me. Yeah.
Curious about this. You are like a blockchain operator. How's the view of the whole process? You have a big picture of the logistics of the whole life cycle. Are you also offering this as a service for people?
Yeah, so Daimler, for example, didn't know what their supply chain was for Cobalt. We told them. Now, we've actually adopted something quite similar to the cloud service agreement that Oracle has with its customers. There's quite stringent controls on our ability to either see or use customers' data. It would be wholly inappropriate, unless I had a very nice fluffy white cat, it would be wholly inappropriate for us to have a true picture of a slug of the global cobalt market, because actually one could misuse that information I'm sure that some commodity traders would like the idea, but one could misuse that data. We want to be a trusted, neutral service provider. Hi. Do we do the supply chain mapping? Yes, we do. Remember the tier one, the OEM and the tier one supplier have the same responsible sourcing charges. So if you're LG Chem or CATL, your brand is just as associated with responsible sourcing charges for things like cobalt or lithium. So it is in their interest to manage this risk as well. To give you a practical example of that, just before Christmas, Amnesty International and a bunch of Congolese cobalt miners sued Apple, Tesla, YU Cobalt, a whole variety of different companies in the supply chain, not all of which were OEMs, basically saying, you have no clue where you're getting this stuff from. You are the reason why these charred miners are digging up cobalt and dying in deep pit mines. So that helps concentrate the mind of the supply chains we're targeting, as you can imagine.
There were no concerns like where
Not from us. I mean, it depends on the supply chain. There's no way that the wing mirror supplier of a car manufacturer will want to tell the car manufacturer all of the whole of the rest of the supply chain behind it, because they'd find themselves disintermediated. But for certain critical materials which have a significant focus from regulators, everybody knows that a greater degree of transparency in the supply chain is actually in their interests, not their disadvantage. And every participant in the supply chain has a unique and important role. If you are a chemical refiner of cobalt, you can't easily be cut out of the chain. You might be able to be replaced with a different supplier. Thank you.
Any questions? All right, well, thank you very much.
Thank you.